Welcome to Bubbles Chemistry. I have baking soda.
And I have vinegar. And when we put them together, we're going to see a lot of bubbles.
For your materials, all you'll need is baking soda, vinegar, and a container. But for more fun, you could always add soap, glitter, or food coloring.
You see here that this baking soda is just salt. Just kind of the same type of thing you'd put on your french fries or your popcorn. So how come it bubbles up when you add it to vinegar?
As you can see, when I pour the vinegar, there's no bubbles in it. So the resulting bubbles from our experiment are not a result of carbonation from the vinegar, but something else.
All right. Hi, friends. My name is Jacob Myers. I am a senior at the University of Scranton. I'm studying right now to try to become a doctor. And right now, we're going to talk a little bit more about the science behind the bubble science that you guys just saw. So baking soda and vinegar, where is the gas coming from? So this is a really interesting question because the baking soda, which is a salt and a solid, and the vinegar, which is a liquid, it doesn't seem like there's any gas there that can form. And so our question has to be, where is it coming from? And so, that's a great question. And I've enlisted Thinking SpongeBob here to try to help us out with it. And so we know that the only things that are present in this beaker are baking soda and our vinegar. So we know that it has to be one of those two things. And to maybe save us a little bit of time, I'll just go ahead and tell you that it turns out that where the gas is coming from is actually the baking soda. And that's not very intuitive, right? Because you would think that this solid that looks like a salt is not containing some sort of a gas, but yet it has the potential to release it. So how does that occur? Well, it happens by a chemical reaction. And you've seen things like this before, and we'll talk about them right now. So you've seen or heard things like this before, maybe in the summertime or at a baseball game or the 4th of July, and the light bulbs might be going off in terms of where this is happening, but we'll switch those light bulbs to fireworks instead. And indeed, what happens with a firework is you have a solid firework, and when you heat that firework up, all of a sudden that solid turns into a gas really, 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 really fast. And it makes a really loud boom that you can hear. And it throws all those burning bits of powder all around in the air. And you can see them. It makes a great light. And you're like, wow, that's so cool. So the same thing happens when we use when we use our baking soda. And we mix it with the vinegar, though thankfully less violently, because we don't want explosions happening in our beakers. And so this is, again, a chemical reaction is taking place. But so what type of chemical reaction is in it, and what part of the baking soda is allowing that to occur? And so the secret lies in the chemical formula of the baking soda and the gas that's created. So the chemical formula is Na, sodium, H for hydrogen, C for carbon, and O for oxygen. And there are 3 oxygens. And the gas that's produced here is carbon dioxide. So do you see how we have CO3 in baking soda's formula, and we have CO2 as our produced gas? So do you see how we might be able to make that form? So the CO3 from our baking soda is going to break down into CO2 and H2O. which is water. And we'll go over that right now. So chemistry time, put on your chemist hats and your thinking hats. This is actually going to be some fairly high level chemistry, but you're all pretty smart. So I'm confident that you'll be able to follow it. So right now we have our baking soda. This is our structure of the baking soda. This is our carbon, the C, the O is the oxygens, these H's are hydrogens, and these little lines here are bonds, but we can just call them lines. And what we want to make here is our CO2, right? This is CO2, carbon dioxide, the stuff that we breathe out, as well as water, H2O, that we drink. And so how do we take this and turn it into this? So there are two things that we need to do. So firstly, you can kind of see how this CO2 is actually, it looks a lot like the CO3 structure here, right? This part of the CO2 structure and this part of the CO3 are identical. And the only thing that we need to do in order to change this CO3 into the CO2 is we need to get this oxygen here to get rid of that minus and to take this line from the other oxygen. And then we'd have our CO2. And the second thing that we need to do is what's currently holding this thing that could be a gas in the solid state. And that's this plus and this minus. These molecules have what's called a charge associated with them. And you can think of this like a magnet, where the north and the south poles of a magnet are going to pull together and hold those two magnets tight together, even when there isn't necessarily a force that would hold, say, a magnet and a piece of plastic together. These two magnets will hold each other together. And the same thing is happening with these two molecules. And so if we manage to get rid of this minus, we're going to get rid of that force. And once we get rid of that magnetic force, this carbon dioxide is going to be able to escape and it's going to be able to leave and form our bubbles. So how do we get rid of this minus? Well, we're going to do that by adding vinegar. And so vinegar is what's called an acid. And what an acid will do is it will put tons and tons of H's into our solution. And what these H's do is they go and find any of the minuses that are present, and they turn that minus into an H, which is what happens right here. And now we've gotten rid of that minus charge, that minus there from the magnet. And so this is going to be pretty unstable. And in fact, it's going to turn into carbon dioxide really quickly, because this oxygen over here, he's a mean sort, and he wants that hydrogen. So he's going to take it, yoink, he's going to yoink the hydrogen. And then this oxygen here, he's pretty sad because now he doesn't have a hydrogen. He's just a lonely oxygen. And so to make up for his loneliness, he's going to take this line from the oxygen over here, the mean oxygen, and yoink it right back. And so now we have our carbon dioxide, right? Because this hydrogen's gone, we have the H with an O and an H over here. And now we have our carbon and the two lines to the oxygen and another carbon, or the same carbon, with two lines to another oxygen, which is our carbon dioxide. So now we formed our carbon dioxide, which is the gas, and it's going to bubble off. And that's what forms our bubbles. All right, so congratulations to all of you. You are a chemist, which is exciting. This was fairly high level chem. So if you follow this, you probably won't run into it again until you're in college. So go home and tell your parents now that you have a college education. But beyond that, so what, right? So why does it matter that we have baking soda and vinegar and it makes bubbles? Well, among other things, this reaction occurs when we make cookies, right? So if I make cookies, I'm going to put baking soda into the batter, and when I bake that batter, that baking soda is going to break down the same way that we talked about here into the carbon dioxide, and it's going to cause those cookies to puff up and be better tasting. And in addition, baking soda is also really important to a bunch of different industries, like making glass for windows, and it's used in some household cleaners. So I hope that that cleared some stuff up in terms of how bubbles are formed when we mix vinegar and baking soda. And thank you very much for watching.